All right, just a quick, disclaimer. Obviously, don't try any of the stuff I'm doing at home. I'm not even an expert at this. However, this is all theoretical, and I don't really plan on doing anything hands-on soon. Like, if you want to know, kind of just like the old gentlemen who have buzz boxes, if you see the Hackaday modified tombstone welder comments, yeah, like 40 years ago they wanted to do that, and they're just getting around to it. I'm still working on projects literally from the late 80s and 90s I've never completed. So these, I don't know, it could be tomorrow. I doubt it. There's probably no way. More like, a year or two out. And it'd be at the end of the winter season where I actually study, electronics. I don't unless it's an indoor season. And the weather's still decent enough outside. I'm working outside on projects. So, it's just, I'm documenting this because I wanted to get this updated from this post here regarding just general Muse about different welding circuits. When I found this circuit, it got me thinking. So I started reading into a little more, and, this video here, the concern for me was like this zero crossing, clipping is what I thought was the term was. So I started reading into clipping, and I was like, oh, that's not really the exact term for clipping. Clipping is cutting off the top. Well, my thought was this is still clipping, but I read a little more. I found where it's zero crossing clipping, they call it. So you can see where he's adjusting his settings. So he's changing not only duty cycle, but he's changing the balance. So the power basically on this side compared to the power on this side, changes. Thing is, I don't like this zero setting. He needs a high frequency circuit for this system to work. So that line's got to have a high frequency signal, so there's always an arc going, so the arc doesn't burn out, and the signal's always continuous. So I'm like, okay, well, I started reading these clipper circuits, and I was like, well, the typical term for clipper, let's just stick with that. I was almost going to go off into clamping, but clipper. And so I started, I did a quick negative series, bias negative clipper circuit. Almost forgot. So, and this was like one of the first ones where I'm like, okay, I'll get the potentiometer. It's kind of just randomly. I didn't do Kirchhoff's rule. I probably should have. But I did just kind of, I did Ohm's law. So I kind of got, I was kind of roughly getting some ideas, just kind of let's throw some values down. So it's very much not inductive at all much. And it was mostly just kind of trial and error deductive. And so this wound up getting let's see, can I zoom in there a little better? Will that zoom for me? It's basically about 120 and then dips down to, let's see here, 20, negative 20. Yeah, you can see the values up here, I guess. About negative 20, goes up to almost 120. So that's that balance, and these are the values for that balance. For more likely welding, I think I calculated this out to be a 70-30 balance. So this is about 119 and then negative about 50. So this design, though, you don't have much for zero crossing. So I'm guessing this is going to be less likely to require a high frequency circuit, to have that plasma, that arc going all the time. I'm wondering if this would go without needing the plasma at all. Ideally, you want a DC waveform that's going to basically be, it goes and that square wave and it just cuts down really quick. But I see sawtooth is used, but I don't know for aluminum. I don't see that. So I'm not sure if this would be that great for aluminum because, again, you want that continuous line going, then quick drop down to negative going for a little bit, rise back up to positive, so you have less chance to lose that arc. If this works, that would be really cool without high frequency. But even if with high frequency, I wonder if this might be an improvement. And super cost effective because you're just using light bulbs. So that's my latest theory. At first, I'm like thinking, totally I need 4,000 watt resistors. What am I going to do? I'm going to have to homebrew them, stovetop elements, quartz elements, for like those little ovens and whatnot, or a stovetop element, or maybe oven elements. You cut them. Put them in a metal shield or whatnot, you know, with some sort of refractory material in, you know, and you have it all in another container with a fan to dissipate the heat, you know, and another big box and whatnot, you know, so you're doing it all safely. But a simple 5-volt power supply, you know, and then maybe just some sockets or a socket, and you just change out the bulbs so you have the right resistance. So doing a quick Ohm's law again, I'm like, well, okay, for this, 300 ohms would be a 43 watt light bulb. I mean, that's it, you know, and then down here, you know, similar, you get like the math for whatever that light bulb would be, and the diode here is really easy, you know, to find at a high enough amp rating, you know, so you have a higher current rating. So that's no problem, but it's like, man, these resistors, the first thought, again, which is which, and what's the logic? So I started thinking about it more. I need to read into it and watch some videos or read, but what got me thinking about the light bulb was this physics website. So here's the link here, and I was like, well, you know, I may not need heating elements. And then I kind of was thinking, is it constant voltage, constant current, so circuit, and then there's a difference between incandescent light bulbs. I think it's a Learn Electronics Repair video. I should have pulled it up and I didn't. Did a good demonstration of if you have like constant voltage, then you're, if you like short out 2 light bulbs or some light bulbs, the light bulbs, intensity does or doesn't change. So it depends, constant voltage or constant current, will those light bulbs dim or not? And so I didn't read into that enough. I just kind of looked at the demonstration. You can tell I don't even remember. I didn't even memorize that. So it was just real quick kind of looking around just to see it. And technically that was just a random YouTube suggestion. So now I think about it, I didn't even look around yet. It was just random YouTube suggestion when I was looking into some other stuff for other projects I'm working on. But I kind of went back to this because I figured I'd do a little update on this circuit because it just seems so simple. It seems like the easiest, most cost-effective way. And the thought was to make this for DC. It seems even super simple is like this output, you know, would go into a transformer, right? And then that transformer output would be what the welder would use. So rectifying after this say there's a transformer here and then I have a rectifier afterwards, say it's just half wave, could I parallel that off and do one half of the wave, one rectification, the other half of the wave, the other rectification, then bring back together in parallel, so now you have each of these waveforms in a square wave rectified. And I don't know if that's going to be the easiest way to do it, but it seems like if I half wave rectified each the top and the negative in separate circuits and brought them back together, I'd have those square waves really cost effective. Is that right or not? And same goes with the light bulbs used, or do I need heating elements or heaters or something? I don't know. If anybody knows, comment down below. I got to look into it. I'll try to update again when I get to reading the theory about more. I probably should do like a more complicated analysis and probably get into like I want to do with Cook's S, or if I get on the Windows machine, LT Spice 4, and see what other information I can extricate out of the schematic. So, okay, that's about it. Comment down below, like, subscribe, and give me some feedback, because I am just stupid about this. My background, even before I had the head injuries, you know, gunshot wound, poisoning, multiple head traumas over the years. Who knows how much? You live in Southwest Michigan or West Michigan, how much you get poisoned. I mean, it's crazy. You get around some of these groups. It's nuts how many different mafias do that. And historically, a long history, it's sad. And then that's not just kinetic stuff. You know, prior to that, man, my training, my degree programming, my work experience was more chemistry and, you know, a little bit of computer information systems compared to the, you know, lab work, you know, whether there's usually more technician analyst work or, you know, R&D work. you know, or business type leadership work. So yeah, this is a self-study all the way. But take care, be safe. Until next time, learn something new and keep Christ with you. Bye for now.